Hello everybody, my name is Alessandro Pio from the Department of Computer Science in L'Aquila and welcome to the presentation of Spark, a project combining artificial intelligence, understanding natural language and geospatial knowledge to deliver a fully customized travel experience. The name of the application shown is Spark, that stands for Semantic Planning with Augmented Retrieval and Knowledge. Let's now get to the heart of Spark, and let's see how it works. It all starts with a web app that runs directly in the browser. Once inside, the user can chat with a virtual assistant. The first message they type, like "I'd like to visit traditional cafes," is processed by an intelligent system that understands not just the word, but also the user underlying intent. This message is analyzed by an NLP module built with Spacey, which compares it to nearby point of interest. These come from a dynamic graph built with OpenStreetMap data and managed using Neo4j. The system filters the results, selecting only the most relevant places using a similarity measure that considers both language and context. Next, a route building algorithm creates a personalized path. It takes into account factors such as time of day, walking distance, opening hours, and variety, aiming to offer a balanced and magnificent experience. For each selected location, the system retrieves up-to-date information using the Tabili API, which gathers content from reliable online sources. This information is then used to generate concise, context-aware description with the help of a large language model. The final output includes an interactive map with the suggested route and set of informative, customized description for each stop. When accessing the Spark web app for the first time, the user is greeted by a login screen. Since they are not yet registered, they proceed by selecting the Sign Up option. The registration process is straightforward. The user is asked to enter a few basic details, such as first name, last name, email address, and password. After successful registration, the user is automatically redirected to the main interface, where they can start interacting with the assistant and exploring personalized routes. Now, let's create our first chat and set the destination to the town of Pesco Costanzo. The system begins by loading the geographic data for the area. Once the data is fully loaded, the chat becomes active. The system greets the user and waits for the first request. The user asks for a walking route starting from a specific location, aiming to visit a traditional restaurant, then a bar, and finally a pharmacy. So it begins by searching for all relevant nearby amenities. It then analyzes the user message with a natural language processing to understand the preferences and to semantically match places like restaurants, bars, and pharmacies. After matching and filtering the most relevant locations, the systems plan an itinerary. Importantly, the itinerary planning may adjust the order of stops compared to the user original request. This deviation happens to optimize the route based on practical constraints, such as opening hours of the venues or travel efficiency. For example, if restaurants open later, the system may suggest starting at a bar or a pharmacy first to better fit the schedule. The final result is a personalized time-aware walking route that balances user preferences with our real-world constraints. In this case, the user opens the sidebar and clicks Delete Chat to remove the current conversation. Since it's the only chat, as soon as it's deleted, the interface automatically opens a new chat window, allowing the user to start fresh right away. Now, let's take a look at another case study, this time in Palermo, to see how the assistant handles a different kind of user requests. In this case, the user asks for a place to get an ice cream while waiting to visit a church, and then needs to pick up a car from a nearby car sharing service. The system quickly identifies relevant spots around Piazza Pretoria and plans an efficient route starting with the church visit, followed by an ice cream break, and then ending at the car sharing pickup. This plan respects the user needs and timing, showing how the assistant smoothly integrates multiple stops into a coherent itinerary without repeating the original order unnecessarily. We conclude this presentation by returning to the main goal of the project, to provide a tool that supports users in planning tourist itineraries in a flexible, contextual, and request-driven way. Spark doesn't just offer a sequence of attractions, it builds routes consistent with the expressed preferences, aiming to adapt to the different ways people experience travel. Thank you for your attention and have a great trip with Spark.